Hello everyone, in this tutorial we're going to sketch the graph of this rational function. Before doing anything, you should always try and factor if you can. And I can see that the numerator is factorable, so I'm going to go ahead and factor it. X minus 4, x plus 1, and over the denominator, which is x. Okay, my first step in gathering information to plot this graph is find the y-intercept. How do I find the y-intercept? Anywhere there's an x, you substitute for 0. In other words, you're evaluating the function at 0, which is equal to 0 squared minus 3 times 0 minus 4 over 0. And that will equal negative 4 over 0, which is undefined. That means there is no y-intercept. Okay? Step 2, find the zeros. And when we say zeros, what we mean is find the x-intercepts. To do that, we're going to work with the numerator. We're going to set the numerator equal to 0. We're going to take the factored form of the numerator. We're going to write x minus 4 times x plus 1 is equal to 0. And then we're going to use the zero product property. That means if x minus 4 times x plus 1 is equal to 0, then x minus 4 must be a 0, or x plus 1 must be a 0, or both. And then we solve for x. X equal to 4, x equal negative 1. These are the zeros, or the x-intercepts. Step number 3 is find the vertical asymptotes. To find the vertical asymptotes, we're going to work with the denominator. The denominator, we set the denominator equal to 0. The denominator is x. So x equals 0 is my vertical asymptote. Number 4 is find the horizontal asymptote. And to find the horizontal asymptote, we need to look at the degree of the polynomial in the numerator and the degree of the polynomial in the denominator. So I'm going to call the degree of the polynomial in the numerator p, and the degree in the polynomial in the denominator q. If the degree is greater than q, then there is no horizontal asymptote. If the degree in the numerator is less than the degree in the denominator, then the horizontal asymptote is y equal to 0. And if the degrees in the numerator and denominator are equal, that means that the horizontal asymptote is going to equal the leading coefficient of the numerator divided by the leading coefficient of the denominator. And later we'll see an example to explain this. Okay? The 5th step I call sign analysis. Sign analysis, which is going to tell me if the graph is above or below the x-axis. And that's going to help me draw this graph. So I'm going to draw a number line. And this number line is like if I were drawing the x-axis. Okay, it's going to help me determine where my graph is. Once I have my number line, what am I going to plot on this number line? I'm going to plot this information. The zeros and the vertical asymptotes. This is the only thing I'm going to write on this number line. So here's what I do. I have a 0 at 4, a 0 at negative 1. So let's find negative 1 right here. Negative 1. There's a 0 there. Let's do 4 over here. 4. There's another 0 here. And we also have a vertical asymptote at x equals 0. So let's say that's right here. And the vertical asymptote is like an imaginary wall. And this is at 0. Okay? There you have it. Now, notice these 3 numbers that I've plotted on this number line. They're called critical points. Critical points because the graph changes every time it hits one of these areas. Okay, these critical points have divided my number line into 4 regions. I have this region here that goes from negative infinity all the way to -1. So here's one interval. I also have this region that goes from -1 to 0. Let's do that in a different color. I have this region here from -1 to 0. I have another region that goes from 0 to 4. And then I have my last but not least region that goes from 4 to infinity. Okay? So I have 4 different intervals, and I'm going to test each one of those intervals. And this is what you do. You choose a number, any number. From negative infinity to -1, choose a number. Let's choose -10. Okay? So this is what I do with the -10. I'm going to plug it in right here to my factored form of the function. And I'm going to say if x is -10 and I subtract 4, will the result be positive or negative? It's going to be negative. -10 minus 4 will be a negative number. I'm not worried about how much that value is. I'm more worried about the sign of that value. So I'm going to say the result will be negative. For the second factor, if I plug in a -10 for x, -10 plus 1, will this result be a negative or a positive number? It will be a negative number also. And if I plug in -10 for the denominator, this will also be a negative number. Now, since I'm multiplying 2 factors here that are both negative, the end result of this product in the numerator is going to be a positive number. I don't care about what number that is, just if it's positive or negative. So negative times negative, positive. And then positive divided by negative, that gives you negative. So that means that this will be negative or below the x-axis all the way from negative infinity till it reaches the 0 at -1. So that means it's going to be below the x-axis. Okay? And later when we graph, I'm going to show you what that means. Now I'm going to test a value that is in the second interval, which goes from -1 to 0. I'm going to choose -0.5. When I plug in -0.5 for x, -0.5 minus 4, will that be a negative number or a positive number? It's going to be negative. -0.5 plus 1, that will be a positive number. And -0.5 will be just a negative number. So now I do negative times positive, negative, and negative over negative, positive. So in this region here, let me change colors. In this region here, the graph will be positive, which means that it will be above the x-axis. Okay? Now let's go to our next region. For this region, I'm going to choose a number from 0 to 4. Any number you want. Let's choose 3. If I plug in a 3 here, will the result be negative or positive? 3 minus 4. That will be negative. If I plug in a 3 here, plus 1, I'll get a positive number. If I plug in a 3 here, I'll have a positive number. So negative times positive, negative, and negative over positive, negative. That means that the graph in the interval from 0 to 4 will be below the x-axis. Okay? For my last interval, from 4 to positive infinity, choose any number you want. Let's choose 100. 100 is greater than 4, right? So if I plug in 100 for x, 100 minus 4, will that give me a positive or a negative value? It will be a positive value. If I plug in 100 here, I'll also get a positive value, and 100 here will be positive. That means positive times positive is positive, divided by positive, positive. That means that in this region, the graph will be positive, meaning that it will be above the x-axis. Okay? Now that I've done my sign analysis, I'm ready to start sketching. And here's what you're going to do. On your graph, you're going to plot all your zeros, your vertical asymptotes, your horizontal asymptotes, and your y-intercepts. You're going to plot everything, all of this information, all of it. Okay, so let's start with our y-intercept. We don't have one, so there's nothing to plot on the y-axis. Let's go to our zeros. I have a 0 at 4, a 0 at -1, so let's plot those. 1, 2, 3, 4. Here's 1 0. Here's another one at -1, right? This is -1. This is 4. And a vertical asymptote at x equal to 0. X equals 0 is really the y-axis. X equals 0 is the y-axis. Okay, so that's telling me that the y-axis is my vertical asymptote, so that's my wall. This wall, this vertical asymptote, we are not allowed to cross it, touch it, nothing. We can only approach it. And the graph usually splashes against this wall when it's near the wall. Okay? So there's my vertical asymptote. Horizontal asymptote, we didn't determine that. I'm sorry. Since the degree in the numerator is greater than the degree in the denominator, that means there's no horizontal asymptote. So I forgot to write no horizontal asymptote. We're done. That's all we have for plotting. Let's go ahead and sketch. And this is what we do. We start from our left. We're coming in from this side, okay? The graph is coming in from the left, and I want to know if it's coming from up here or from down in this region. And how do we determine that? Well, this is what we do. I'm going to use blue. I look at my sign analysis here. It says that the graph comes in from -infinity all the way to -1. It will be below the x-axis. Here's my x-axis right here. So it's going to be underneath the x-axis. That means I'm going to be right here underneath. So this graph is coming from negative values, okay? And anytime I have a 0, the 0 will pull or attract this graph towards itself, okay? The zeros will attract the graph toward themselves. So I know I'm coming in from a negative value. I'm approaching the 0. And since it's a 0, that means that my graph will cross this 0. And if you notice here in my sign analysis, when I reach this point of -1, after -1, notice that the graph is above the x-axis. That means I cross it and now I am above, right? I'm above the x-axis. And notice that I have a wall. I have an asymptote, and whenever I have a wall, the graph will approach the wall, get really close to, oh, this is bad. Let me hit undo because that's really ugly. Okay, I'm going to try again. It's going to approach the wall, but never touch it. And it will get closer and closer and closer to the wall, but it will never touch it. And there's that part of the graph. You're coming in from negative values because it says here below the x-axis. Once it hits that 0 at -1, now it's above the x-axis. Here it is, above. And it hits the wall. And we're done. Since I can't cross the wall, I have to stop right there. I have to stop graphing. Now I'm going to look what happens. I'm going to look at what happens behind the wall. Behind the wall, it says that the graph is again below the x-axis. So here's the wall. I'm behind the wall. The graph is in the negative part, or below or underneath the x-axis right here. And if I look at my sign analysis, it's going to be underneath the x-axis all the way till I reach the other 0, which is 4. And since this is a 0, this 0 will pull that graph towards itself, okay? And it will cross, and once it crosses, it will be above the x-axis, which is what it says here. So I'm going to go ahead and below the x-axis right here between 0 and 4, and since this is a wall, graphs behave near walls, they will splash against the wall. So I know that I will reach 4, I will be very close to this wall, I will splash against it, I will not touch that wall, okay? I will reach the 0, I'm underneath the x-axis, right, till I get to 4. Now I'm going to be above, because that's what it says next, above, I cross the 0, and I am above. And I will continue to go on forever, and there's your graph. Isn't this beautiful? I'll see you in the next video with another example.